Wants to try at this one. Surprisingly, it's a very different problem than the first warm-up, but the same steps apply. So the first part was drawing a diagram. We have a child sliding down a hill. Remember, whenever we're doing these angles, we're trying to make it so that it's clear where the angle is. So we don't want like a 45-45 triangle. So drawing an extreme triangle always helps. Try a different drawing program. We'll see how it goes. So we have a kid on a sled. And we want to know how long it takes him to go down. The hill is 85 meters. And there is friction between the sleds. So the coefficient of friction we're given is 0.1. It doesn't say static or kinetic, so we'll just have to you assume it's kinetic because you'll be sliding, and we'll just use that value. And we want to find how long it takes for him to get down to the bottom. If we say sledding, it never says anything about initial velocity, so I'll assume that the initial velocity is 0. That's usually how people go sledding. And that looks like the diagram. So the next step was to do the free body diagram. So we have this person on the hill. Maybe I'll just do this free body diagram on top in a different color. And we have the person, there's definitely gravity on the person. So I'll put mg there. Friction is going to act against motion. So we got the force of friction up here. We can maybe go a little bit thicker. Not that thick. And then we have the normal force. So maybe that's a little thick too. Whoa. All right, the next step here is to break this into components. And since we have a ramp and the person is going to be traveling along the length of the ramp, it seems like the easiest component fix would be perpendicular to the ramp and parallel to the ramp. I think down the ramp would be positive, and above would be, well, we could do that's positive too. Or we could say down's positive. It's kind of up to you guys. I'll go down. Down is positive. That'll make gravity in the positive direction, so we can just say the force is down. So I'll say down is positive here. Kind of like this other pen. All right, that would be step 3. Step 4 is to break into components. The only component we have here is this one, and you can see there's our right triangle, and that's also 15 degrees. So the vertical part here, we call that FG normal, and then we have FG ramp, which is the part of gravity pulling it down the ramp. And if we write those out, FG ramp, it's the opposite of the angle, so it's going to be mg sine theta, and FG normal, it's going to be mg cosine theta. All right, and now we apply Newton's second law. So in the perpendicular to the direction, looks like the force is balanced. So perpendicular, we have that the FG normal is going to equal the normal force. And parallel to the ramp, there's going to be a net force because there's going to be acceleration. He's going down the hill. That's what sliding is. And so it looks like F ramp is trying to make this guy go down the hill. And it looks like the force of friction is opposing it. And that's going to be our net force down the ramp. And that's going to be equal to the mass times the acceleration. Once we have acceleration here, we can then go to and find, once we find out what the acceleration is, then we can find out the delta t, which is what we're trying to find here. So if we fill this in, FG ramp is going to be mg sine theta. I'm going to try a different brush. How do you change the brush size? Well, there we go. All right, we got mg, oh, not that one. All right, we got mg sine theta. The force of friction, well, that's mu Fn equals ma. Now mu Fn is just going to be mu, because we know Fn is going to be equal to Fg normal. And Fg normal we just wrote out as mg cosine theta. And here you can see we got an m here, an m here, and an m here. And the masses all cancel out. And that's good for us because they never gave us the mass. So from this here, you should be able to get the acceleration. And once you know the acceleration, then we can go and use our oldie friend equation, vi delta t plus 1/2 a delta t squared. So now we can find a. We know vi is 0. We know delta x. We should be able to find out delta t. Make sure you're in degrees. A lot of people are submitting answers in radians, and sometimes it gives you answers that seem reasonable, but they're wrong. And sometimes it gives you answers that are just wrong, like negatives where they shouldn't be. I always check that you're in degrees. Good luck.